Welcome to my LeetCode 423 weekly contest 423 live stream. Yeah. If you're here for solutions, jump ahead to 90 minutes in or use the timestamps in the video description. In a few minutes, we'll be doing the contest live and answering questions and giving hints in the chat. So come join us every weekend for the contest. No code will ever be shared while the contest is running, but immediately after it ends, we will go through all 4 questions. So if you enjoy LeetCode contents, do check out the rest of my channel. I have videos on different problems as well as the hardest question 4s of previous contests. And as usual, like and subscribe to stay up to date on new videos. Okay. So, welcome everybody to the contest. We are about 3 minutes out. And we're waiting for people to stream in. So for folks who have never who have never joined my stream before, once again, we don't share code online. We will never share code online. But immediately after we finish, we will go through our 4 questions. So don't worry, if you want to know answers, just sit tight, wait until the contest ends, and then we'll go through our answers. While the contest is running, if you get stuck, do ping me on the chat, and I will try to help you out as much as I can. Again, not by sharing code, but by discussing the question and giving some hints on which directions to go. So we're gonna start in another couple minutes. 1 minute actually. I'm thinking of, I was actually working on today's daily problem. Today's daily problem is not super hard, but I need to get to it after the contest ends. I don't think I have time to work on it right now. We're only a few seconds out. 45 seconds out. The contests, I feel like, have been getting harder for the past few months. Or at least it seems that way to me. Even the first few questions are getting harder and harder. So don't worry, you don't get the first few questions done. You know, just if you're a learner, focus on learning, and don't focus too much on the outcome of the contest itself. Okay, we're 17 minutes out. 17 seconds out. It looks like it's going to be a quiet stream tonight. If you have questions, okay, cool. Contest has begun. Good luck, everybody. First question. Yeah, I should probably flash the question on screen. So first question is zigzag grid traversal with skip. You're given an m by n 2D array grid of positive integers. You get to traverse the grid in a zigzag pattern while skipping every alternate cell. Zigzag pattern is as follows. Start from 0, 0. Move right within a row until the end of the row is reached. Drop down to the next row. Okay. So if I were to visualize this. So you start here. Move until the end of the row until it's reached. And then drop down to the next row and traverse left until the beginning of the row is reached. So it's something like this. And you keep going. So note that you have to skip every other alternate cell during traversal. Okay. So for instance, 1, 2, you skip 2, you have 4, and then you 3. So why this is like this is you start from 1, you go to 2, you go to 4, and then you go to 3, but you skip every other cell. You skip 2 and you skip 3, and so you get 1, 4. And likewise, so likewise for this one, you traverse. This is but you skip every other cell, and then you get 212. So this one gives you 212. Okay, this is not a super difficult question. Remember, if you have questions about the problem, feel free to ask in the chat. I'm coding off screen, so you might not see me do anything on screen. If you don't see me do anything on screen, don't panic. That's not because I'm slacking off, but it's but it's simply because I am working on. I'm on a different screen. So if you ask questions, I will come talk to you. Once again, if you're new to the channel, just say hi in the chat if you need help. If not, then I will just work on my own stuff, and I may not interact super a lot with the chat. We may not interact. I may not be doing a lot on screen. If I'm not doing anything on screen, it's fine. There's nothing scary about it. But if you talk to me in the chat, I will help you. Okay, so question 2. Maximum number of amounts of money robot can earn. Robot. Wow, I like robot questions. You're given an M by N grid. A robot starts left hand corner. Wow, grid again. So many grids. You want to reach the bottom right corner. The robot can move right or down any time or point in time. The grid contains a value, ij, in each cell. If the number is larger than 0 or equals to 0, the robot gains that many coins. If it's smaller than 0, the robot encounters a robber, and the robber steals the absolute value of those coins. So if it's positive, you get coins. If it's negative, you lose coins. So the robot has a special ability to neutralize the robber at most 2 cells on its path. Okay, preventing them from stealing coins in those cells. Okay, so I think this is something that most of you have seen before, right? You have a grid. You have a bunch of coins. Oh, actually, I can use the grid in the example. I bet there's a grid in the example. Oh, there's no grid in the example. Damn it. So let's say the input coin is here. Is 0, 0, 1, minus 1, 1, minus 2, 3, 2, minus 3, 4. Okay, and I'll erase the rest of the grid. Let's say this is your grid. Okay, so you want to get from here, beginning, to the end. And you can also only move right or down. And at every point, you can neutralize. You can neutralize the robber. If it's negative, you can neutralize the robber. So you can move here. Let's use a different color. You can, let's say, move like here to here to here to here. You get 0, 1, -2, 3, 4. You get all these coins, but you can neutralize at most 2 robbers. So you neutralize this robber. You neutralize this robber, you will end up with 8 coins. So this -2 doesn't count because you can neutralize this robber. So that's basically what the question is asking for. This question is very similar to the standard question of asking what's the path with the maximum number of coins. The only gimmick here is that you can neutralize up to 2 robbers. So think about how to go about doing that. So think about how you can keep track of how many robbers have been neutralized. Again, if you need help, come talk to me in the chat. I will attend to you shortly. In the meantime, I'm sort of working on my own. Yeah, I'm working on my own problem. Okay. Actually, I want to see how big the field is. Oh, the field is only 500. It's a very small. It's a very small field. Oh, this is a very quiet screen. Second one is DP. Yep. Second one is DP. Consent buy and sell stocks for neutralizing counts. Like we use in buy and stock. And most free stocks. Is this correct? Maybe. I feel like that's. Yeah, that's not a. I wouldn't. Yeah. Yeah, basically much. It's DP with account. So one extra axis on the DP. Yeah. I would say that's the right way to go. Yeah, so instead of like a 2-dimensional or 1-dimensional DP, you add one more dimension, which is how many more robbers you can neutralize. So you either neutralize 0, 1, or 2 robbers. When you reach 2 robbers, you cannot kill any more robbers. If you're less than 2 robbers, you can still kill robbers. Yeah, second one is kind of a DP problem. Yeah, well, it's not kind of. It's almost exactly. It's definitely a DP problem. 2D or 3D. You can write it as a 2D problem, but 3D is the more intuitive one. So think of like you have the basic 2-dimensional grid, right? You have one more dimension, which is how many more robbers you can neutralize. So think about it that way. Kakarot. Yeah. So always fun. You're absolutely right. Yeah, I think the second problem just takes a bit more bookkeeping. Otherwise, it's not super difficult, I think. I don't think it's super difficult. Alright, let's see what happens. So once again, for people who are new, if you have question, ask in the chat. I'm working on a separate screen, so I may not, not may not, but I definitely will not see your question. I will not show the answers. But if you ask questions, then I will try to help you. Again, reminder not to share any code on the channel. Alright, let's see. Okay. Yeah, it does take a while to do the bookkeeping. I'm also trying to do bookkeeping, try to make sure that everything looks correct. Getting a bug here. I'm getting a weird bug that I'm trying to solve. Okay, so 0, 1. Okay, row 0, column 2, n equals 0. A is -1. Okay. Okay. I'm getting a weird bug that I'm trying to solve. Neutralize means set, yeah. So neutralize means set it to 0. That's what neutralize means. Because if you don't neutralize it, then you lose money. So you don't want to lose money, you set it to 0. I'm getting a weird bug here. Okay. Let me see. So 111 011 111. Okay. So this is a two-dimensional DP. I think it helps to just draw out what the numbers will look like in the whole grid. It will help to draw out what the numbers will look like in the whole grid. The maximum of this. So maximum of Okay. Let's see if I got this right. Oh, it's still wrong. Damn it. Well, the idea for question 2 is quite straightforward, but I feel like the actual execution is tricky. At least for me. Trying to figure out the 3-dimensional DP is a pain. Row 1, column 1, robot equals to 1. Okay, let me see. Row 1, column 1, previous 1, previous 2 equals to 1. Coins RC. Coins RC. Why is it 1? Damn it. Why is this? This is so weird. Okay, n equals to 0. So this is option A. Option A, previous 1 plus coins minus 2. This should be minus 1. Zero. Wait a second. N equals to 0. Okay, so this should be minus 1. RCN should be minus 1. Okay. So minus 1, 1. Okay. I think I'm getting somewhere. Finally. Okay. Minus 1, 1. And then this should be 1. Okay. This should be 3. It's a 4, and this is 1, 1, 4. 3, 4, 4, yeah? Okay. So this is 3, 3, 3. And 3 minus 1 and 3 minus 3 is 0. It's 4. So the best I have for here is okay. Hopefully this is correct. 8 and 40. Let me see if I got 8 and 40. Okay, 8 and 40. Okay. So this looks correct. Finally. Okay, just to double check to make sure that my math is correct. Actually, let me just submit this. See what happens. Hopefully this is correct. Wrong answer. Ah, damn it. Oh. Okay, I got a really weird. Okay. I read 2 to Nishan Lam. I read question 2 to 4 and gave up. Yeah. So we don't give answers, but the idea is on the screen. Basically, as others have described it, is a DP problem. It's kind of a 3-dimensional DP problem. So you think about it, there's 2 dimensions, which is the grid itself. For each cell in the grid, you want 3 dimensions, which is you keep track of how many robbers there are. So it's a 3-dimensional DP problem. So we don't share code on this channel, but if you want just the answers, stick around after the contest. We will go through the answers after the contest. So I'll share code after the contest, not right now. Okay. Okay. I've got a weird problem. So it says that so it looks like it cannot neutralize once you reach the bottom. Neutralize robots in at most 2 cells on its path. Wait, this is very I got a very strange wrong answer. It says that, okay, guys, I got a really strange wrong answer. Maybe somebody can tell me if you got this answer also. So I got this answer that says -4. This one should give you -4, but I think this one should give you 0, because you just neutralize this 1 cell. Steals the absolute. Robot's total coin spam can be negative. Yeah, I don't get it. Why is this? I don't get it. This is very strange. Okay, I'm gonna try again. Okay, please, fingers crossed. Oh, still wrong answer. Why? 59 and 60. Oh my god. Okay, let me see. Let's see. So I've got another one that is a bug. 7 minus 7, 12, 12, 13, minus 6, 19, 19 minus 6, 9 minus 2, 10, 10 minus 6 plus 16, and then minus 4, 14, minus 10, minus 9. Okay, so this square will be minus 7, 0, 0. This square will be 5, 12, 12. Okay, so this square is going to be 17, 24, 24. And then this square is 30, 37, 37. Yeah, so this looks correct so far. Huh. Okay, so this square minus 6, so it's minus 13. So minus 6 and then 0. Okay, so this square is 5 plus 5 minus 13. It's going to be minus 8. Minus 8 plus 19 is going to be 11. Wait, that's not right. Okay, so 5 plus 19 is going to be 24. Yeah. You don't have optionized. Maybe you don't make any moves. Yeah, so that's what I'm thinking of, Nishan Lam. That's what I'm thinking too. So don't ask for solutions. So please don't ask for solutions or answers on this channel. Let me just write it in the chat. Please don't ask for solutions or answers. If you have questions, I will try to give hints. And that goes for everybody else in the channel too. If you know the answer, just give a hint. Don't share any code. Yeah, because you share code, you're gonna get caught, and then we're all gonna get in trouble. And plus, this is also a contest. We don't want to, we want it to be fair to everybody, right? So we don't allow sharing code on this channel. Huh. Yeah, could it be that the first move you're not allowed to take from 0, 0? Yeah, that's yeah. Yeah, try your best. We'll go through all the answers after the contest finish. So if you stick around, we'll go through all the answers and I'll be able to give you in-depth solutions too. So don't worry if you don't get it. There's no shame in trying and failing. Um exactly like Nishan says. Yeah, because I'm gonna tell you right now, I'm also trying and failing. Yeah, this thing is hard, dude. This thing is hard. Yeah, there's really no shame in trying and failing. I guarantee you that is true. 5966. Huh. I can't figure out what I did wrong here. This looks all looks correct. So I really can't figure out what I did wrong here. Let me see. Uh 1, 2, 3, 4. So let me add the calculator. So 1, 2, 3. 12 plus 19 plus 19 plus 16. 2, 3, 4, 5, 6. Oh, neutralize 2 robbers. Okay. Yeah, there's really no shame in trying and failing. Yeah, dude, it is the real sin is this being labeled medium. God damn it. I feel like LeetCode contests are getting harder and harder. It's getting harder and harder every time. I'm actually low key mad about it. Okay. Okay. I found a bug. Like there's a bug in my this should be 1, 2, 3, 4, 5, 50. 50. And then this is 43. Yeah, this is correct. So if minus 6 will be 37. Oh, okay. I found what's the bug in mine. Either pref 2. Okay, please, no more wrong answers. God damn it. No more wrong answers, please. Okay, finally I managed to get question 2 done. That took a while. It's not a tricky question per se, but it's a lot of bookkeeping with a 3-dimensional DP. It's annoying to say the least. Alright, question 3. Minimize the maximum yeah, you finally found question 2. Good job. Yeah, I also got 2 wrong answers. Yeah, oh my god. Yeah, so SST, yes. Hint for question 1, just maintain flag for storing and traversing 2 flags. You're good to go. Just figure out a way to store, do the zigzag. And then just like SST said, just maintain a flag to say skip, don't skip, skip, don't skip. Nice, always fun, good job. Yeah, I got lazy, so I coded in a weird way. And I got a lot of wrong answers to that. So maybe next time I'll do it better. You are given question 3. You're given 2 integers n and threshold, as well as a directed weighted graph of n nodes from 0 to n minus 1. The graph is represented by 2-dimensional, edges, weighted, it's directed weighted graph. So A, B, W means A to B with weight W. There's no B to A, just A to B. You remove some edges from this graph so that satisfies the condition. Node 0 must be reachable from all nodes. The maximum weight in the resulting graph is minimized. Oh, interesting. The node has at least at most threshold outgoing edges. Okay, so for instance, in this example, we want 0 to be reachable for all of them. And then what's the rule? The rule is minimum possible value of the maximum edge weight in the resulting graph is minimized. Maximum edge weight. Okay, so edge weight is just the weight of individual edges. So in this case, the maximum edge weight is 2, is my understanding. Has at most threshold outgoing edges. Oh, that's a lot of stuff. That's a lot of stuff to deal with. Okay. The maximum edge weight in the resulting graph is minimized. Each node has at most threshold outgoing edges. So return the minimum possible value of the maximum edge weight after removing necessary edges. If it's impossible for all conditions to be satisfied, return -1. Okay. So threshold is 2. So maximum outgoing nodes is 2. Has at most threshold outgoing nodes. So I need to remove. Okay, well I don't. So this is kind of a weird criteria. At most threshold outgoing nodes. This is kind of weird criteria because what we want to do is to get rid of as many. We want to. Actually, no. This is the weird criteria. The maximum edge weight is minimized. Of course, you want to get rid of all the edges that you can, right? We want to get rid of as many edges as we possibly can. So at most threshold outgoing nodes, it's kind of weird. I think most of the time it doesn't matter. It's just certain cases it does matter. So for instance, in this case, we want this graph to be 0 to be reachable by everybody. So this is the best way to do it. If we get rid of this, then the maximum edge weight will be 1 because all the weights, all the edges have weight 1. So the maximum is 1. And it also obeys the 2 outgoing threshold thing. Okay, so the next one. So 0, 1, 2, 3, 4. 2, 3, 4. So 0 to 1, 1. 0 to 2. Oh, wait a minute. It's 0 to 1, not 1 to 0. 0 to 1 is weight 1. 0 to 2 is weight 2. 0 to 3 is weight 1. 1 to 2 is weight 1. 1 to 4 is weight 1. So there's no way to reach 0. In fact, nobody can reach 0. Nobody can reach 0. Yeah, these are directed graphs. So nobody can reach 0. So in this case, the answer is -1. So in this case, 1, 2, blah, 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 blah. Threshold is 1. So let's see. You want to reach 0, right? You want to reach 0. That's kind of your rule. You want to reach this guy. So you want to reach this guy, you have to keep this. This is reachable. These are all reachable. So you can keep either this or this. 2 or 5. So in this case, I can delete the 5. I can delete the 5. And 3 still can reach 4. And 1 still can reach 3. Okay. Can I delete the 3? I can also delete the 3. 1 can go to 2, 3, 4, and then 0. So I can delete both 3 and 5. If I delete both 3 and 5, the maximum weight among the remaining edges is going to be 2. Okay. So it sounds like, okay, the threshold thing is throwing me off a little bit. If I ignore the threshold, it sounds like what I want to do. If I ignore the threshold, then it sounds like what I want to do is I want to start from the heaviest edge and then delete it. And then see, is it still a fully connected? It's like, can I still reach 0? Man, how is this question medium? Damn it. Hey Rohan Sharma, welcome. Don't worry about being late. Just if you want, you can just jump in the contest. Oh, but it might affect your rating. So it's up to you. Yeah, I don't care if I'm late, I just jump in anyway. And my rating is terrible. But it's okay. I have fun. Always fun, yeah. I don't understand why. Why is -4 output expected 4? It should be expected 0, right? It makes sense because I have a negative number. I can neutralize 2 robbers. I'm going to neutralize this guy. I don't understand why it's -4. I think that is the question is bugged. I think the question is wrong. Okay, let's see. Threshold is, yeah. So hint for question 2. Hints for question 2. Let me just briefly go through it again. It's basically a 2-dimensional DP problem. It's a standard DP problem where you want to find, for each node, you want to keep track of what's the best value you can get at that node. So for each node, you can either go from come from the node above him or come from the node on his left. So you just go row by row, right? You solve the first row and then solve second row or solve third row. And for each row, each cell, you check the node above me and the node to my left. What is his best way of getting there? And then plus myself. Now, in this case, you can neutralize 2 robbers, so you need a 3-dimensional DP to solve this. That's the hint. I hope that's helpful, Junaid Ahmad. Okay, this man. Okay, so I'm tempted to start by the sort of straightforward method. Let me look at let's look at last example first. So last example is 0, 1, 2, 3, 4, and 5. So 1 goes to 2. 1 goes to 3. Wait, 3. 1 goes to 4. Wait, 5. And then 2 goes to 3. 2 goes to 3. Wait, 2. And 4 goes to 0. Four goes to 0. Wait, 1. Okay. Yeah, so this is impossible because nobody can reach. Only 1 and 4 can reach 0. 2 and 3 cannot reach anybody else. Yeah, so if I ignore the threshold, I'm tempted to just ignore the threshold and see what happens. If I ignore the threshold, then my strategy. If I ignore the threshold, my strategy will be start from the heaviest node first. I'm going to say this is the heaviest node. Heaviest edge. If I get rid of him, do I still have a graph? If this is the heaviest node, if I get rid of him, do I still have a way of getting there? That's my basic strategy. So one way I'm thinking of is to sort of arrange everybody radiating outwards from 0. So I start from 0. Who can reach from 0? I sort of reverse the direction of the arrows. I can reach 4. Okay, who can reach from 4? I don't care about the furthest, the total path cost, right? I don't care about the total path cost. So 4 is connected to 3 and 1. If I reverse the direction of the zeros, 3 and 1. So 1 goes to 3. And then 3 is connected to 2. Yeah. 2 is connected to 1. Yeah, that's not gonna work. That's not gonna work. Yeah, I was thinking just delete these kind of intermediate paths, but that's not gonna work. How many nodes are there? Let me check how many nodes are there. 10 to the power of 5. So this is very large. I cannot even do if I do a nested loop, this will fail. How do I do this? Let me think for a while. I need a way to quickly find if I need a way to quickly determine if I can reach this without this edge. Yeah, I don't know. I feel like there should be a standard algorithm for this. Yeah, let me look at the last question real quick. So count non-decreasing subarrays after k. You're given an integer nums of n integers and an integer k. For each array of nums, you can apply up to k operations on it. Increment any element of the subarray by 1. Note that each subarray is considered independently, meaning changes to 1 do not persist. Subarrays that can make non-decreasing after performing at most k operations. Damn, this is also DP. This is also DP. And k can be very large. Oh, so maybe it's not DP. K is too large to be DP. Increment any element of this subarray by 1. Okay. So this one will not even let you do n square. This is 10 to the power of 5. The number of subarrays that you can make non-decreasing. Okay, so I guess you can count how many subarrays are there that are non-decreasing that end with a number. But if you use a DP approach, these numbers are too big for DP. If you have one row for each k, yeah, that's going to be too big. Wait, so subarray is... So subarray, oh, it's not... Subarray, is it contiguous? Does it have to be contiguous? 3136? 631? Yeah, so it has to be contiguous. 21 possible subarrays. If there are 21 possible subarrays, okay, so they have to be contiguous. The subarray has to be contiguous. Yeah, this is so this is definitely a DP. So you need to increment everything by 1. That's different from decreasing by 1. Okay, I'll probably start from this side. From the I'll reverse nums, and I'll instead of non decreasing, I have to make this strictly non decreasing, so only goes up. Wait, hang on. Is it non decreasing or non increasing? Oh, these are non decreasing. Non decreasing. So 6, 3, 1, 2, 4, 4. Yeah, I don't know about question 4 also. O(n) square is not going to pass for sure. It's definitely not going to pass. So if something like 6, 3, 1, 2, 4, 4, did you try every single one? Is that how you got O(n) square? So one thing you can do is to find because it's contiguous, right? You to sort of find the difference between this and the last element. So the difference between this is 0. The difference between this is, let's call it -2. Oh, this is +2 because it's non-decreasing. This is 1. This is -2. This is -4. So if I work backwards, okay. So if I work backwards, let's say I start from 4. Okay? So I have how many sub-arrays are there ending with that start from 4 and are non-decreasing with at most k operations? Well, there's one subarray that ends with here. What about this one? So 4, 4, and 4, there's 2 subarrays. What about this one? 2, 4, 4. Okay, so this is 1, 2, 3. This is 3 subarrays. So it starts with 2 and is non-increasing. Non-decreasing. So what about this one? This is going to be 4. There are 4 subarrays that start with 1 and are non-decreasing. What about this one? 3. How many subarrays are there that start with 3 and are non-decreasing? Well, for 3 to, so one option is just 3 itself. If I want 3, 1, I have to spend 2k. Yeah. Okay, the problem is I not only have to spend 2k, I have to spend some of my k to make this thing go up. I have to spend k to make all of these go up. These guys have to go up too. Huh. Yeah, these guys have to go up also. So I have to find the first number. Oh, wait a second. So basically, I have to find the first number I'm larger than, which is 4. Okay. So I have two sequences who starts with 3. And I don't have to spend any k. Oh, it's going to be n squared if I do that. Yeah, I don't know. This is tricky. Yeah, so question 3, I'm not super sure either. So question 3, I think the strategy is to find the heaviest node and then remove them. But you need to know. Yeah, you need to know if you need to know if it's still. Yeah, you need to know if it's still a connected graph. Yeah. Yeah, I'm actually kind of stumped. Or the other way I can do it is to start from. The other way I can do it is start from 0, and then I will add the some minimum spanning tree that's the cheapest. So I start from 0, and I look at the cheapest, all the outgoing nodes from 0. I look at the cheapest node. So cheapest node is 1. So I reach 4. And at 4, I look at the cheapest node from 4. Or from all of them, actually. So in this case, it's 2. But I don't know if. Oh, actually, yeah, that's possible. So look at the cheapest node at every time. How many nodes how many edges are there? Are there a large number of edges? Oh, I guess it is a fairly large number of edges. But I can't do this. Cannot do this. I can arrange all the edges by their weight. By their weight. I arrange all the edges by their weight. And then at every time, I'll look at the cheapest edge. Yeah, but there's no quick way of doing this. That's going to be n squared also. I want to look for the cheapest edge that connects to one of my existing nodes. Yeah. Yeah, I gotta. This is tricky. Third question. Yeah, what's the third question? Don't overthink it. Yeah, I don't think I have time to finish the third question, unfortunately. Yeah, but well, it's, I might try after the stream ends. But well, while I do have everybody on this stream before it ends, if you do enjoy the channel, I'm gonna do my usual plug, which is I really appreciate you just click the like button here. If you like what I do, leave a comment on the stream once it's up, and yeah, if you want to come back and watch this contest next week, then remember to subscribe to my channel. I don't know if I'm streaming next week. I may or may not be. I need to check my schedule. But usually I will stream all the bi-weekly contests, and the weekly contests I will stream when there's no bi-weekly contests. Hint. Yeah. So don't ask for code. No, I'm gonna So don't ask for answers on the channel. So don't ask for code. Yeah, fourth one timeout. Yeah. Yeah, it's unfortunate. Yeah. Don't ask for answers on this channel. At least not while the contest is running. After the contest run is finished, just do whatever you want, right? While the contest is running, we want to make sure there's competitive integrity, and also like LeetCode. I think the learning is more important, but LeetCode has very strict contest policies. So if you fall foul of the contest policy, you share your code, somebody else copy paste. They are very good. They're not very good at finding cheaters, but they are very good at finding people who copy paste code. So if somebody else copy paste your code, then you will get in trouble. Yeah, why not? Did the third question. I'm looking at fourth one for a long time. Third question isn't hard. Don't overthink it. Yeah, I don't think I'm going to be able to finish it. Third question. How do you do it? Third question. Do you find the Do you just delete the heaviest node? Do you just keep deleting the heaviest node each time? Or do you find like a minimum spanning tree? But it's not a minimum spanning tree, right? That's the answer may not be a minimum spanning tree because it's looking at the weights of the individual edges. Add in, okay. Yeah, you start that's what I was thinking too. You start the lightest and then you add in starting from the smallest node, and then you keep going until you manage to get a spanning tree. You manage to add all the nodes. Yeah, I guess, yeah. You know what? That makes a lot of sense. Yeah. Yeah, why not? That's a great. I hope I'm saying your name right. Sounds like why not? It's a pretty cool name. Yeah, that makes sense. So Levy or it's like the Pokemon. Okay, all right. My Pokemon is not that advanced. Yeah, Akshat Khandawal. I don't know if any. The fourth one, I think it's like super hard, even globally. So Levy. Yeah, so Levy, you probably have a bug in your DP. I had a bug in my DP too. So you probably had it looks like you had a bug in your DP because you got pretty close to the answer. Levy or Levi. You got pretty close to the answer. Okay, so the contest is almost ending. I'm gonna chill out a little bit. I'm gonna grab some water. And then we'll come back in 2 minutes. I'm gonna discuss the solutions that I know of. I think the third one, I'm just gonna explain why not's solution because I didn't manage to get it either. Badass contest. You did a 3D, so suck needs Sensama. You did a 3D DP question on my own. Congratulations. It is not easy, dude. It is not easy. So you should be proud of yourself. I'm gonna grab some water. I'll be right back in 1 minute. $3DDP. Yeah. I mean the thing is that the basic idea is not is not extremely challenging, but it is a lot of bookkeeping. Not sure if this is a minimum spanning trees. Yeah, it is kind of like a minimum spanning tree, similar. Okay, so contest is ended. Let's move on to discussion. But before I do that, I need to do my usual YouTube. This is for people who sort of jump halfway into the video, so it's easier for people to follow. And let me just check. This is 432. Okay. We are discussing solutions for LeetCode Weekly Contest 432. Jump to specific questions using timestamps in the video description. Check out the rest of my channel if you enjoy LeetCode content. Like and subscribe to stay up to date on new videos. Once again, I stream every week for the weekly contest. Bi-weekly, I will stream the bi-weekly contest if it's available. If the bi-weekly contest is not available, I will stream the weekly contest. So I stream every week. Welcome, check me out. All right, cool. Let's go with the discussion. Just bring up the chat, see what people are saying. Yeah. Okay. So, we're going to go through each of the questions one by one, starting from first one. I tend to do the first few very quickly so that we can go on the more interesting ones. So question 1, zigzag grid traversal with skip. You're given an n by n 2D array grid of positive integers. Your task is to traverse grid in a zigzag pattern while skipping every alternate cell. So zigzag pattern is defined as follows. Start from top left, move right until the end of the row is reached. So start from top left, move right until the end of the row is reached. Drop down to the next row and traverse left until the beginning of the row is reached. So drop down one and then go back here. And then you just keep going. Yeah, that's the basic idea. That's the basic zigzag. Okay. And you continue alternate blah blah blah. Now you must skip every other cell during traversal. So this one, yes. This one skip. 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 This one, yes. Yes, yes. So on and so forth. So that's the basic idea, right? To put it in pictorial form. Here's a pictorial example. So start from 1, you do zigzag like this. Okay, you skip every other cell. So this one, yes, no, yes, no, yes, no, yes, no, yes. That's the zigzag pattern. So how would you, and then you're supposed to print out all the numbers that you selected. Well, how are you going to do that? Well, you basically break it down to two parts. You have one part that does the traversal, and you one part, some logic that will handle the skipping every other cell. So let's start with the traversal first. The traversal is pretty straightforward. You have a nested loop. And the idea is you, for each row, you figure out, you get R equals to row, grid row. And the idea is when you're traversing a column, if the row is even, you go from left to right. Okay, so V equals to R column. So the column it goes from 0 to the width of the grid. If the row is odd, you go from right to left. So V equals to R minus 1 minus column. This negative number will tell Python to go count backwards from the end of the grid. Yeah. So this is the part. When the row is even, you traverse from left to right. When row is odd, you traverse from right to left. If you're in Python, you'll probably write like M minus column, something like this. So as column increases, your index decreases, and you're traveling essentially from right to left. And the other part is just a binary Boolean flag that says, do you want to output or you don't want to output? And every time you move a cell, you just flip the show to its opposite number. And if you do this, you'll be able to get this pattern that you see on the left. Okay, this is pretty straightforward. I don't want to spend too much time on it. Maximum amount of money a robot can earn. Actually, let me just take a look at the chat. So why not? Yeah. You visit a set that includes 0, then throw in all the edges. Yeah. This is, yeah. So this way you can only, yeah, you're correct. So this way you don't have to search for the cheapest. You just like sort all the edges. Yeah, that's a good idea. So Suckneed sends Sama, I started panicking on this first question. I just if else the reset of the inner loop. Yeah, the inner loop sort of goes from left to right or right to left, right? It's kind of wonky a little bit. Yeah. So you gotta figure that out a little bit. Okay, second question. Maximum amount of money that a robot can earn. You are given an m by n grid. A robot starts at the top left hand corner of the grid 0, 0 and wants to reach the bottom left corner. Okay, another grid problem. Gee, thanks, LeetCode. Robot can move right or down. So each grid contains a coin. If the coin is larger than 0, you just take the coin. If the coin is less than 0, you will lose the coin because the robber steals it from you. So basically, if the thing is positive, you just take it. If the thing is negative, you lose that many coins. Now, you have one more special ability, which is you can neutralize robber. What that means is you can pick on your path, you can pick 2 negative cells and neutralize them, which means set them to 0. You can set them to 0. And so your job is to figure out what's the maximum profit that you can have. So take, for example, this one. So 0, 1, minus 1. 1, minus 2, 3. 2, minus 3, 4. Okay, you want to start from here. You go all the way here. Let me change a different color pen. You want to go from here all the way to here. Okay, so your job is to pick a path. You want to pick some path that will maximize your profit. So I think the best path that you have looks something like this. And your profit on this path is you just add them all up. 0, 1, minus 2, that's the negative 1, plus 3, that's positive whatever, plus 4. Okay? So the only catch is you can neutralize on this path. The sort of value of this path is all the numbers on this path, but you can choose 2 numbers up to 2 numbers. So you're going to obviously choose the negative numbers. You can choose 2 numbers and neutralize them. So I don't like this negative number, I'm going to neutralize it. I'm going to neutralize this robber. So the value of this path is going to be 0, 1, 3, and 4, which gives you 8. And I think this is the best that you can do. If I'm going to pick another example, let me see if no other example. So that's an example that we are going to go with, right? So how are we going to do this? How are we going to do this? Well, first of all, there's a very standard problem that says it's exactly the same as this problem, except there's no robber. There's no ability to neutralize the robber. So in the very standard version of this problem, you basically have a 2-dimensional DP. At every point, you calculate what is your best possible score. So for instance, let's say you're here, right? Your best possible score is going to be 0. There's no way to get better than 0. Okay? Let's say you're here. Your best possible score, you have to come, there's only one place you can come from, is 0. And then your best possible score is going to be 1. And here, there's only one place you can come from. Your best possible score is going to be 1 plus negative 1 yourself, which gives you 0. And likewise, this is going to be 1. This 1 minus 2 can come from above here or on the left like this. So you pick the source that is better. So in this case, this is 1 and this is 1. They're both the same. So your best possible score is going to be the max of these two, which is 1, minus your plus yourself, -2, you get -1. And then so on and so forth. So 3, the best possible score is 0 and 3, so it's 3. There's only 1, so it's 3. Here 3 and -1. Well, the best possible score is going to be 3. 3 minus 3 is 0. And then here the best possible score is going to be 7. So 3 plus 0 plus yourself, 4. Max of 3 and 0, which is 3, plus yourself, which is 4. Now, this is the version where there's no way to neutralize robbers. What do you do if you can neutralize at least one robber? Well, at every point, you just check. You just check if you can neutralize yourself. So, for instance, if you can neutralize up to one robber, here is going to be 0 again. Let me use a slightly different color. It's going to be 0 again. Even more different color. It's going to be 0 again. Okay. This is going to be 1 again. This is still going to be 1. At this point, you can actually choose to neutralize yourself. If you neutralize yourself, you would take this one and this one, compare them, and then put it here. So you neutralize yourself, your best score is going to be 1. But this number -1 is you didn't neutralize anybody. This number 1 is if you neutralize yourself, or you neutralize at least one thing on your path. Okay, this is the best score you'll get if you had neutralized at least one thing. Okay, so what about here? 0, 0, 3. This is if you neutralize yourself, you're going to be 1. If you neutralized one thing on this path, 1 and 1, it's going to be 1, and so on and so forth, right? So I think this is going to be 8. This is going to be 3. This 1 and 1. If you neutralize yourself, you're going to be at 0. That's the best you can do. And this is going to be 8. I think. Yeah. So what happens when you neutralize? You can neutralize 2 robbers. You can neutralize 2 robbers. Then what you want to do is look at this number before. You want to look at this number before. So let me choose yet another slightly different color. Okay, you can neutralize 2 robbers. Well, 0, it doesn't matter. 1, it also doesn't matter. 1 also doesn't matter. Here, it also doesn't matter because you have already neutralized 1 robber. Here, you can actually neutralize 2 robbers. So you're going to look at this guy and you're going to look at this guy. So you can, what's your best? It's still, well, it turns out that going this path is still better. Going this path is still better. So this is still going to be 0 because you will neutralize yourself. Yeah. So the basic idea is, so that's basically the basic idea. So for every grid, you have 3 numbers. The first number is what's the best value of value of a path ending here if you don't neutralize everybody. Second number is you neutralize 1 guy. Third number is you neutralize 2 people. So if you want to know what's the value of let's say this third number, you will look at the value of these 2 guys before them, where they have neutralized up to 2 people, and then you add yourself, or you look at these 2 guys before you, and you look at these 2 guys before you, so you neutralize only 1 robber, and you can because they only neutralize 1 robber, you can neutralize yourself. So that's the basic idea. So it's a 3-dimensional DP. It's 2-dimensional in its base form, and for each of the cells you have 3 numbers for how many robbers you have neutralized up to that point. Yeah. So the basic code looks like this. It turns out there's a lot of bookkeeping. So row, column, and n, which is the number of robbers you neutralized. So you want to find out what is the so-called previous cell. So you sort of take the best score of your left and your top. You take the best score of your left and top. If you don't have a left or you don't have a top, you just take the other one, where the n, the number of robbers, remain the same. Or you can take the best of your left and your top cell, where with n minus 1, okay? And in this case, you are neutral. This is assuming you can neutralize yourself. This pref2 is what happens if you neutralize yourself. Okay? So you want to figure out, basically, you want to figure out what is, you want to figure out what is the best version that you can do, either by taking, let's say n is 1, you've neutralized 1 robber so far, then you can either check the best value you have, either coming from the left or the top, where you've neutralized 1 robber, or the best coming from top or the left, where they have neutralized 0 robbers and you get to neutralize yourself. Yeah, that's what this thing is basically doing. Okay, so if you run this, you'll end up with a 2D DP grid, and then you take the last grid, bottom right corner, and you have 3 numbers there. You take the maximum number, and that will be your solution. Okay, this is not difficult conceptually, but it's like super annoying to do bookkeeping. Okay, let me read the chat real quick. They should have accepted, so Sugnit sent Sama, they should have accepted DFS on this, but 3D DP was fun. Yeah, it is a very anxious DP way. I usually write a backtracking solution, isolate the variables you need to pick. The total amount you collected, the number you skipped. Yeah, so DP XY skip is the total number you collected. Yeah, the bookkeeping gave me a headache too, Saki Sensama. So, yeah, you and me both. You don't, do in the third loop. You just do 0, 1, 2. Yeah, so why not you don't have to do the third loop at all? You're right. You can just, because there are only 3 numbers, right? So check the 0, check the 1, check the 2. It's actually, in fact, you don't even have to check the 0. You don't even have to check the 2. You just check 0 and 1. Recursive DP and got wrong answer. For this one. So Kiran, yeah, that's interesting. I also got wrong answer for this. And when I wrote it out, I realized that I made a bug. And so Kiran, this exact thing is the guy that cost me a bunch of time. Yeah, this one is the reason why I took so long to solve the problem. The bookkeeping definitely gave me a headache also. So, it happens to everybody. So Yash Gupta, you're only able to solve 1 question. It's alright, dude. Don't worry about it. These contest questions are getting more and more ridiculous. I'm kind of mad, to be honest. They're getting more and more ridiculous. Okay, question 3. Minimize the maximum edge weight of graph. You are given 2 integers n and threshold, as well as the directed weighted graph of n nodes, numbered 0 to n minus 1. The graph is represented by a 2D integer array edges, where edges I equals ABW indicates there's an edge going from A to B with weight W. You have to remove some edges on this graph, so it satisfies these conditions. 0 must be reachable from all other nodes. The maximum edge weight in the graph is minimized. Each node has at most threshold outgoing edges. So return the minimum possible value of the maximum edge weight after removing the edges. If it's impossible, return -1. So minimum value of the maximum edge weight sounds like a mouthful, but let's look at some examples to see what it's actually doing. So look at this one. Okay, so the idea here is you are allowed to remove edges so long as everybody can go to 0. Everybody continues to reach node 0. It must be reachable. And you can remove as many as edges as you want, right? The rule, however, is the maximum. You want to minimize the maximum edge weight in the graph. So what's the maximum edge weight? It's the weight of the heaviest individual edge. So in this case, the maximum edge weight is 2. But if you delete 2, the maximum edge weight is going to be 1. We're not actually looking at the weight. We're not looking at the cost of a path from anybody to 0. I don't care how long it takes in total. I just care about the weights of the individual edges. I don't have to add up the weights of the entire path. I just look at the weights of the individual edge. Which edge is the most heavy? So in this case, 2 is heaviest. I delete 2. Now I check, is it still connected? Yes, it's still all connected. Great. So the maximum edge weight is going to be 1. The other example is this. In this case, I want to make sure everybody can reach 0, right? Now there are a lot of ways to reach 0. What happens if I delete number 5? I can still reach 0, and my maximum edge weight is now 3. Okay? So that's kind of good. What happens if I delete number 3? Well, my maximum edge weight is now 2, and can I reach 0? Yeah, everybody, node 1 can still reach 0 using this circuitous roundabout route. It's not actually the cheapest route, but I don't care about the cost of the total path or route. I just care about the maximum weight of the individual nodes on the path. So how do you do this? I didn't manage to do this during the contest itself, but yeah, but the basic idea, one of the the viewers on chat, why not, suggested doing sort of a reverse minimum spanning tree. So instead of deleting edges on the graph, what you want to do is you want to add edges on the graph starting from the cheapest one until you're able to reach every single node. So in this particular example, right, the first step we want to do is to arrange all the graphs by their weight, starting from the cheapest. So the cheapest, 1, 0, goes to 4. Okay, I have another 1. 1 goes to 2. Okay, and then I have weight 2. So 3 goes to 4. I have another weight 2. This is 2 goes to 3. And then I have a weight 3. This is 1 goes to 3. And then weight 5 is 1 goes to 4. Okay, so first step is to arrange all the edges by weight, because I want to minimize my weight, the weight of the heaviest single edge, right? I don't care what the cost or path or whatever. I don't care about those. I just want to add these edges, but I want to add. I don't want to add the heavy edges. I want to make sure the heaviest edge is as light as possible. I don't want to add these 5 and 3. Yeah. So that's my goal. So what I want to do is to start from the cheapest edges, and I want to keep adding them until I reach every single graph node. So I start with 0. So I only have one node, node 0. Okay. Now I'm going to add this edge. 4 goes to 0. Okay. This gives me 0 and 4 in the connected graph. Now I'm going to add this edge. 2 goes to 1. Oh, this one actually doesn't do anything. This one actually doesn't do anything. I'll have to connect the 2 and the 1 somewhere else. Yeah. And yeah, I got to think about, actually, yeah, I haven't thought about this part yet. So I have to record this. 2 goes to 1. This has to be connected somewhere else. So now I have to do 2. I know 3 goes to 4. So I have 0, 3, and 4. So 3 goes to 4. And then I have 2 goes to 3. So 2 goes to 3. This allows me to have 0, 2, 3, 4. 2 goes to 3. And then from here, I actually get the 1. So at this point, after I add the 2 goes to 3, at this point, I have a spanning tree. Well, not actually a spanning tree. Everybody can reach 0. So that's the idea. So at this point, everybody can reach 0. Because everybody can reach 0, I think you probably need some kind of adjacency matrix to store this. You probably need some kind of adjacency matrix, I think. Yeah, I'll have to think about it a little bit. But after you reach this point, you now know that you now have a graph where everybody can reach 0, and the smallest weight is going to be 2. So the answer here is going to be 2. So that's the basic idea. Yeah, I think I'm going to store this as a set of edges. I'm not sure. I have to think about it a little bit. So let me read the chat. Yeah, don't add 2, 1. Yeah, don't add 2, 1. You only look at things that have 0 and 4. Yeah, so the threshold requirement, I don't really understand. Yeah, I don't know why they added it. I feel like there are some edge cases that might need it. Yeah. Yeah, you have to keep the 2, 1 somewhere. Yeah. Okay. Cool. If you don't understand if you want more details on this particular problem, you can also read the chat. I think Why Not is giving a pretty good explanation, probably more detailed than I was giving. So you can read the chat to see if that's helpful to you. Okay, so the last question. Yeah. I can send you my submission, don't know how. You can actually copy paste from LeetCode. Yeah. Actually, you can just, let me see. Yeah, let me see if you can do this. Pretty sure I've done it before. Like you can get this submission. Yeah, I need to check how. Sorry, I'll check how, and I'll figure it out by next week. But basically you can get a link to this page, your submission. And I think I'm pretty sure to do that, you need to get out of the contest mode. You need to look at this as a regular non-contest problem. And then you'll be able to copy your submission, and then you can paste it. So if you're able to create a link, then add it to the comments in the video, and I'll pin it so that other people can use it. Yeah, so why not? You have to figure out how to link your code. I don't actually know how to link code. I remember I've done it before. I think the trick is like you have to not look at this as a contest. You have to view it as an ordinary problem. Oh, okay. So go to a contest page, click on this. So you see the contest disappears from here. So now you can go to submissions. You go to your submission, and then you can, let me see. Yeah, you can go to your submission and then just like copy paste it. There should be a link. If you copy paste it, you run it, you should have some submissions here, because the contest problems are recognized differently from regular problems. So you have to go to the page where this is regular problem and then submit from there. Okay, let me just briefly go through question 4. So count non-decreasing subarrays after k operations. You are given an array nums of n integers and an integer k. For each subarray of nums, you can apply up to k operations and you can increment any element by 1. Note that each subarray is considered independently. Return the number of subarrays you can make non-decreasing after performing at most k operations. So yeah, so basically there are n square, kind of like approximately n square subarrays, half n square subarrays. So in this example, 6 3 1 6 3 1 2 4 4. 1 2 4 will be non-decreasing. 1 2 4 4 non-decreasing. 2 4 4 non-decreasing. 3 1 it's not non-decreasing, but you have k, right? If you take the k, you replace this one by 3, and your k goes from 7 down to 5. This will also be considered non-decreasing, because you can increase this 1 twice to become a 3. Your k goes from 7 down to 5, so you use 2k, and this will be non-decreasing. So there's a whole bunch of things that are non-decreasing, but out of these 21 possible sub-arrays, these 2, 3, 4, these 4 cannot be made non-decreasing after applying up to k operations. So it makes sense, right? So let's say 6 3 1. If you want to make this non-decreasing, you can only add, you cannot subtract. So this has to go up, go up to at least 6. So this is, so this is non-decreasing. This is going to cost you k equals to 3k. So your k from 7 now become 4. So now this one needs to go up to 6 also. So for this to happen, your k has to go from 4, it has to go to 5. And that's not going to happen. Yeah. So how do you do this? I didn't manage to do this, but I feel like I might have an idea. I might have an idea. Yeah, the basic idea is, if I want to make it non-decreasing, I have to increase everybody to at least the same as me. Right? I have to increase everybody to increase. Yeah, I don't know. I have to think about it a little bit. Yeah. So for instance, if I want to make, so my idea is to go backwards, and every square I figure out how many subarrays are there beginning at that square that are non-decreasing. So this will obviously be 1. There's only one subarray, 4. This will be 2. It's 4 and 4 4. This will be 3 2 2 4 2 4 4. This will be 1 1 2 1 2 4 1 2 4 4. So this is 4. This one is trickier. So for 3, you have to see if I want to make this. If I want to make this non-decreasing, yeah, I have to go from the beginning. So if this, it's the next one, right? So if I want to make the next one non-decreasing, I have to increase it by, I have to find the first index that is larger than, I don't know. I have to think about it. I basically, at 3, I need to know that 3 and 1 is going to require how many k I need. And then 3 and 2, I need to know how many k I need. And so on and so forth. So I kind of need to figure out, like, I think it's some kind of prefix sum, if I'm not mistaken. Some kind of prefix sum. Some kind of prefix sum that helps me determine how many I need. Yeah. I keep going until I reach something that's greater than 3. Yeah. I'm not sure what the solution is here. I think about it a little bit. If you know what the solution for question 4 is, feel free to write it in the comments. It's going to be really helpful to myself and also to the others. Yeah. All right. So that's pretty much the end of the stream. Let me see if there are any questions. Yeah. So why not if you're able to? So let me see how you can do it. I think how you do it is you go from you see the weekly contest. What you want to do is go back to the contest screen. You click on this. This will bring you. Oh, you got to refresh. Refresh and click on this. You can see that the URL is different. This URL has the words weekly contest in it. This URL does not have the weekly contest. So you take the URL without the weekly contest. Oh, I lost my answer altogether. You take the one without the weekly contest. Let's say pretty sure I can do this. Then submit. You'll get a submission link, and then you can use this copy link. And you can copy link and paste it in the comment section. And this link will actually have the answer right here. So that's how you're going to do it. Okay. All right. Yeah. If anybody else wants to, you can see the num1 answers. Yeah, you can see the answers too. So the problem with the number 1 answers is that they tend to be not very readable. At least that was my experience. Let me see. If I go to here, I look at the oh, this is not too bad. This is definitely readable. There's some very not readable ones. Yeah, so this is still not too bad. This sort of, you can follow it. There are no comments, unfortunately. But it still sort of makes sense. Yeah, I like that this guy who won actually programmed in Python. Usually the people who program in Python don't win. You see, it's mostly C++. And yeah, it's mostly C++. And Java, some Java at the bottom. Yeah, so it's great that we have a Pythonista who won. Yeah, so this is still okay. I think this is still readable. Some of the C++ answers are very unreadable. Okay, this is not that great. This is kind of like, because the variable names are like this, and then you don't know what they're saying, right? So the variable's name is not description. There are no comments. It becomes really hard to decipher what they're actually doing, which is a problem, I think, with competitive programming in general. This is, what is this, what is Q, is not super obvious. At least not to me. Yeah. So I normally don't read their solutions. I feel like the Python ones sometimes are better. But the C ones especially like when they start doing, and they don't do it here, but especially when the C people start doing like bitwise operations, then it becomes hard to read. Okay, so if anybody else wants to submit their solutions, you want to share their solutions, on the channel, feel free to just copy and to paste your link into the comment section. I would love to hear from you. I also love to see how many questions people solved. I feel like the questions are getting harder and harder. So let me know if you think that's true. Or is it me? I'm just hallucinating. We'll see. Alright. So this is the end of my stream. Thanks everybody. I think cause after LLM. Yeah, I think so too. Maybe. Anyway, this is the end of my stream. Thanks everybody for tuning in. See you guys next week.